Yeah. Is this clear? Apparently not, but is this clear? I mean,
It is.
It is, right? Okay. I don't know what else to say because we're running through an example. I think, yeah, if you solve this on your own and like have your own rough work, it'll be more clear. So when I get to 9, instead of 7, I look at the max of 7 and 9, so that'll be 9. And then I get to 2. At 2, what is the depth? 1, right? Then I look at 2 and 3, which is max 3, so I just leave 3 there. I execute this part of the code.
So I was just wondering,
Yeah.
like the difference between, like when you said DFS, is it like an in-order traversal you're doing right here?
No,
I treat out as DFS.
there's a lot of difference between in order and DFS.
I treat out as DFS, right? And you travel over till the depth at one.
Yeah.
Yeah.
Yeah, so DFS can combine like many things. You post order, pre-order, and in order can be done in a DFS way. Just saying DFS does not characterize, in a tree at least.
In fact, tree is a graph, it is not acyclic, so
Yeah,
the DFS is in fact the way of traversal.
yeah. If you want to do in order, so a normal DFS is I look at the topmost node, and then I go along this path until I reach the leaf, right? But the order in which you're visiting those nodes, that means doing something with the information in those nodes. For a normal DFS would be like root, it's left, it's left, it's left, it's left. And then the last guy that, at least for that path, the last guy I'll be looking at is the leaf. But for in order, the first guy you need to be looking at should be the leaf. Because that's the one with the smallest value, right? So there's like a subtle difference. Okay, so now we are at 2 and depth is 1. And I look at index 1, the value that's already at index 1 and the root. So this guy is not the max value. I already encountered something else that depth, so I don't do anything. And then I go here, and then I compare 11 and 9. And this is of depth 2. And this is the max value that I have seen of depth 2 up to this point, of 7 and 9. So that's why I have 9, but 11 is even better, so I just put 11 here. That's what this else clause is about. That's it. Does this not make sense to anybody?
It does.
It does, right?
That if made a lot.
Yeah. If it's not, like, maybe you should ask me which part is not clear. Are you guys good? Okay, can you like elaborate on which part is not clear?
I can't understand
Yeah.
the else sentence.
Okay, so you can't understand what this does
Yeah,
or when
yeah.
you will get to else. Okay, what this does, right? Yeah. So the else goes, it will get into the else clause if I'm looking at a certain depth, but my list is bigger than that depth. So that means I already encountered a node in that depth. So at each depth I have many nodes, right? So the first time I'm encountering a node of that depth,
Yeah.
I just add it to the list. Because if depth is equal to largest values dot size, that means in my list I do not have something for that depth. Because the size, the index will be 1 plus the current size, right? Does that make sense? Yeah. So if I've not seen anything at that, if I've not seen a single node at that depth, then I add it, right? And that's how I know, like doing this check. So I do this if I've already seen some other node at that depth. So if I've already seen another node at that depth, and I want the max value for each depth, then what do? I look at the current max at that depth and myself, right? If I'm looking at depth 2, I see what is the maximum at depth 2 that I have until now. And the max value of that depth that I have until now is that guy. It's already in there with this, the max value for each depth. So I just compare my current and the max value that I've seen so far for that depth. And I put that at that index. Okay?
Same.
Yeah, cool. Okay, let's move on. There's like other problems that are fun. Out.
Just going leftmost. It's just the left. No, it's left is not.
See, if it's just the leftmost, then I just take the root, go left, left, left until it's not.
But if
That's
left
done.
is not there, then what should be said?
But that's not what they're asking. They're saying leftmost node in
So if left
the
is
last
not there,
row
then
means at the
we have
max
to go and
depth.
check the
Yeah.
return right.
Yep. No, one sec. one sec. So in this case, you just have to output this. Because the last row is the deepest row, right? The one that's at the maximum depth. There, so I could have this also.
Maybe, I mean, when we can traverse and if the depth is like higher than the previous, then we can update it.
Bus. But how do you know that that's the leftmost node? So it's not just the deepest node. You need to find the leftmost node at the deepest level.
So you can have a structure
Okay.
with the index and the value over there.
What does
Which started
okay?
from initially at 0 at the parent.
Okay.
Structure with
Okay.
the initial value of 0 and then the value, whatever value is there.
Okay.
You travel through the left.
Yeah.
I mean, at each level.
Yeah.
And only update, check if the structure value
Yeah.
is less than the current index left value.
Okay.
Only leave you want to update.
See, there's no less or more. There's no max.
Yeah.
You
so
just
we want
find.
to check if our left is a leaf or not. If it's a leaf,
Yeah.
then update the structure value with that. If the value is maximum or
It does not have to be a leaf.
sorry.
I mean, it has to be a leaf.
We
It's
check
the
the index
minimum.
basically.
Yeah.
I mean, what I
Yeah. What is that index?
What is that basically? So in the structure you save the depth
Okay.
and
Yeah.
the depth or whatever and
Yeah.
the root value what you want to set.
Yeah. Okay.
So you keep on traversing.
Yeah, I get you. So what you're saying is, if you get to a new depth, in my structure will tell me whether I've been to that depth or not. Right?
Yeah, where the depth is yeah.
So
So
it already found
Correct.
some
Already
room in
Yes, but
storage.
my question is, there could be many nodes at that depth. So many times you'll get into that situation.
So
where
if it is a bottom-up approach, the first ever node that we visit
awesome,
is
great, that's awesome. Like this kind of like intuition comes only with solving problems. So if you want to get to the leftmost node of each row, and if you do DFS, then the first node you hitch for each step is the leftmost.
Then we can update that it's already found.
Yep. So you update it only the first time you get to a new depth, and you just keep quiet if you're getting to new nodes at the same depth.
So we need two. One is the depth and
Yes,
the
other
other
one is
is
the
where we
value.
found it.
No, the value. It's
Ah.
not whether you found it or not.
Oh,
Because you're just supposed to return a value.
but if we need to compare that, like,
leftmost.
am I moved out to this depth or not, right? If you
Sorry?
so how do you keep track of
Yeah.
whatever left leaf value at different level of nodes?
You don't have to keep track of the left leaf at a different level of the nodes.
Then how do you
I have only two integers.
ah,
Okay.
Depth and
What is the max depth I've seen, and what is the leftmost value at that depth.
Okay.
Okay? Let's say I get to a new depth. Then I compare it with the current depth. The new depth will be more
So
than
you are
current
global,
depth.
yeah. Okay.
Yeah, global value. So once I'm at a depth more than whatever I encountered, I update the value. And at that point, I can either visit the ones that are even deeper, or the ones that are at the same depth, or even the ones that are above. But you only update if you're like getting even deeper.
As your depth increases basically.
Yeah, yeah. And you do it only the very first time. So let's look at the code for this. This is interesting. There is like multiple ways of doing this. You can also do like easily. You can do like so many things. You can get the level order traversal for the entire tree, and then just get that one value in the last.
Yeah.
There's like many ways to do it. You can also do this with post order. So I ask my left subtree to tell me what is the deepest node that you found on its left side, and this guy also, and then I compare the depths. And I only take the one on the left side. If the depths are the same. If the right depth is greater, then I take the one on the right side. Right? But this is like, this involves writing like the least code.